Hello everyone, welcome to lecture 3 of 580. And today in this lecture, I will finish basic concept in Python programming by introducing object-oriented programming. And I will talk about Numpy array, which is a useful module for working with matrices and vectors in Python in an efficient way. So let's start with last topics that I talked in the previous lecture, which was introducing module and how we can use module in Python and how we can import them. So module are Python package. Means that we have a module, and in the module we have a collection of function and variable that we want to use in another program. So, for example, you have a module that you define some variables and functions, and you want to use that in another project. You have to import these function and variable in another file. So load module into your code using import statement, and the import, and how do you can import them. You can use the import keyword in Python and then mention the module name that you want to import. So there are useful built-in module in Python, and you don't have to define them. You just need to import them and use them in your program. So Python has a number of very useful built module for this string. We have a module string, and you can have lots of operation on a string without actually coding them. You just need to use these function in the module string. So there are lots of useful function in the math module, and for example log, exponential, and you just need to import math in your file and start working with this function. Another useful module in the Python, iter tools, and which is a iteration tools for the sequence data type, for example list, tuples, and the old sequence data type that we saw in previous lectures. And you can have lots of functions, for example, combination, permutation, cross product on this sequence data without actually implementing that. There is a very useful module in the Python that I used lots of function in them in my research. For example, the name of the module is a random, and if you want to generate some random numbers and sampling from different distribution, you can use this random module, which is so useful for research or coding and generating random numbers in the Python. Another one is the RE, which is a regular expression. If you are working on text strings, you can use this module because there are lots of functions useful for search and manipulating strings using RE and its functions. And this is the whole thing that I want to talk about the module. And let's start talk about the object-oriented programming, which is a useful concept in programming, not just Python, in other language also. And objects or like function are a tool for organizing program. An object consists of a collection of related information, for example, variable, name, and information that we want to have in this object, and a set of operation to manipulating and access that information that we define for the object. So if you want to define an object, for example, you can see everything in the world like an object. For example, dog, cat, everything is a lot like an object. And for example, we have some function that an object can do, and there are lots of features and attributes in the object that we want to define for programming. So I will show some example of that, but let's say the other information that we can have in the object. The information is stored as an instance variable, and for the operation, we call it methods that we can have in the object. And all the information and method that we have in the object we can call them attributes. For example, you can consider dog as an object, and instance variable are the name of the dog and the tricks that the dog can do. Right, these are information that we want to know about the dog. And the method that we can define for a dog object is bark. And also we can teach trick to the dog, and after teaching trick, we can ask the dog to do some trick about the trick that we teach to the dog. So now we consider dog as an object, and we define some variable for that, and there are some methods or function that we can define for the dog object. So you can see everything in the world as an object and define some variables for that and define some methods for that. In this case, we can organize the program, and we can define a class object. For example, we can define a class for the dog and start to generating different dog with different names and different tricks that the dog can do. So we can create a new object type in Python by defining a class. And once you have defined the class, you can create an instance of the class. For example, after defining the class of the dog, you can get an instance, for example, the puppy dog that we can have different names and different tricks that this instance of the class can do. And you can think of a class instance as an object which has specific values for the instance variables and can perform the member functions. And you can define multiple instances of the same object type. For example, you can define lots of dogs with different names and different traits. And so each one has an instance variables and methods. An important concept that you want to know about the classes is the constructor, and all class definition must define a constructor method at the first, which is the underscore init underscore, and the constructor is a function that we want to execute just after defining an instance of the class. So the constructor can be called to initiate a new object with with that class type, and the constructor often take arguments and which can be useful for initials and instance variables in the class. And also don't forget that all the members, all the function that we have in the class should get a special argument, which is self, which refer to the instance that we just create. For example, if we want to generate an instance of the dog, self in the function that we define in the dog class is referring to this exactly same instance that we create. For example, dog puppy, self means that puppy. And that would be more clear if I can show some example of the class for defining a class. For defining a class, you need to have a keyword of the class, and just by typing class as a keyword in the Python. So after class, you can have the class name, and then we have some indent to show that we are defining some variables and function for this class. And at the first, you need to define a constructor for the class, which can be defined by underscore init underscore. And you should pass self as an argument, as a parameter to this class. And the other parameter that you want to pass to the constructor. And then define some members variable and assigning value for them. So this is the constructor of the class. And then we can define some function, for example, member function, and then note that also we should pass self to each function that we define in the class, and then pass some other parameters, and there's a body for the function. So let's see an example of the dog. Here I define a class of the dog, and I define a function for the constructor, a function for teach trick, and another function for do trick. So the function, the dog class has two variables that are name and tricks, and we define the variables in the constructor, and in the constructor we pass self and the input name that we want to have for the dog. So self.name means that the name of this instance that we just create. So if we get the input name from the user, for example, puppy or something like this, and then we assign the name of the dog with input name that we get from the user. And the tricks at the first is empty, but we define the type of tricks, which is a list, because there are lots of tricks that the dog can do, and then we define that in the constructor. after executing the constructor, the Python knows that we have a class of the dog, which name is the input name, and also we have a list which is empty of the tricks, right? So we define another function which is teach trick, and we pass sub as a variable to every function that we define in the class, and we also pass other parameters that we want. Here we have for example, here we have just one parameter, which is the trick name, and then this means that we teach this trick name to the dog. So we just need to add this trick name to this list that we have just created. So self.tricks.append and add the trick name to this list that we have for this dog. And also, if we want to do trick, we just need to print that the name of the dog and then the trick that we want to do with this dog. So we just need to get the length of the tricks that we have in the self.tricks, and then -1, because if you remember, the index in the Python is 0 based. So if we have just one member in the self.tricks, means that the length of the self.tricks is 1, and which then 1 minus 1 is equal to 0. So if we want to do a trick from self.tricks, which has just one member, so we can use random.randint 0, and n also is 0, and I here is 0, and we can return the first tricks that we have for the dog in the self.tricks. So after that, also you can note that here we just used random module that we talk about it, which is a useful module in the Python, and you can generate a random number. So for example, if we have 5 tricks in the self.tricks, we want to just select one of them randomly and print the name of the dog and print that tricks, and means that the dog did this trick as an operation. So yeah, after defining the class, we want to get an instance of this class. How we can do that? So there is a comment, and then you can just print the name of the class and pass the argument or parameters that we defined in the constructor. So here we have input name. We want to mention the name of the dog, which is a Spot, and then construct the instance of the dog class, which is Spot. Now we can teach some tricks to this dog by passing the name of the trick. Here you can see that we have a trick name, and for example, rollover, and then after this, the rollover will be added to this trick self.tricks list that we have, because we append the name of the trick to the tricks list. So after this, the tricks the tricks list has just one member, and After that, we can call do trick without any argument. Here you can see the parameter that we passed are just self, and we don't want to do that in calling the dot function. So we just have spot dot do trick parentheses. So after that, the program print the name of the dog in this line, the name of the dog, which is a spot, and the name of trick, which is rollover. So this can be so useful because you can define different instance from dog class, for example, another dog by another name, and other tricks that we can teach to the dog. And also comment that can be so useful for documentation and writing notes about your code in Python. So how we can define comments in the Python. Comment cannot be executed by the Python, but that would be so useful to use them in the Python code, because sometimes you need to write something for yourself or for other people that are reading your code. So that would be so useful. You can just write some to-do list for the writing code, or you can describe the name of the function. You can describe the input and output of the function in the comments. So if you want to have just single line comment, you can use this sign, and you can also have multiple line comment with putting 3 of this sign and then end it with 3 other. And another important point in the writing code in Python is don't try to mixing tabs and a space when you are intending code, and that causes an error in your program. Because, for example, here you want to indent your code here after defining class. You can use space or tabs, but don't try to mix them. You should be consistent in your program. So now you know Python. You know the basic concept in the Python. And you can write the code in the Python by knowing them. But there are lots of information that if you want to a professional programming coder in the Python, you can learn them. But we just learned something basic Python in this in this course, and the goal in this course was to knowing something quickly and focus on some basic that can be useful for research purpose. And for example, you can use this concept for other advanced course, for example, course 5089, which is machine learning. So now we are moving on to learn something about the numerical Python. And NumPy is a module which is so useful in programming in Python, and is the backbone of the Python scientific programming stack. And NumPy provide a multi-dimensional array or tensors, and the reason that we are using NumPy is that most of the function written in C, and the code in the C can be run so quickly, more efficient compared to the Python. So if you want to use these features in the C, we write some function in the NumPy and try to use them in the Python. So if you have some codes that iterate over lists and arrays, that would be better to use NumPy because they are so more efficient, and that can be run in less time compared to other functions that we have in the Python. And as I mentioned, many useful functions for speeding up loops over array elements can be accessible in NumPy. And if you want to use NumPy in your code, you can just need to import NumPy and then define another name for the module. You can have import NumPy without as not NP, but that would be better to have import NumPy as NP, because every time you calling the function from the NumPy, you need to type NumPy dot, for example, math or another function. But if you change the name of the module as an NP, that would be more easy because you have just need to enter NP dot the name of the function. So the core of NumPy is the array type. You can define, for example, here, you can import NumPy as a module, import NumPy as an NP, and then we define an array, which is a kind of a list. But here we just define the list as an one-dimensional array in the NumPy. So np.array 1, 2, 3, and then we print the A, which is an array of the list. So flexible structure for storing typical scientific data, and you can have numerical data, matrix, and you can have image pixel values. For example, you know that for each image and for each pixel that we have in the image, we can have 3 values, RGB, and you can store them in the NumPy array as a 3D, 3-dimensional matrix. And also you can have 3D images such as MRI scan data. All of them can be stored in the numerical data, which is the NumPy array. And you should know that you can change the content of the array after defining the array, but you cannot change the size of the array. For example, here, the size of array is 4, but you cannot change the size of array. But you can change for example, the first element that we have in this array. And in general, we cannot use mixed types data in NumPy array. So if you want to make an array, or we want to construct that, how we can do that? So you can define a one-dimensional array, and you can define two-dimensional and three-dimensional arrays. So if you have, for example, a list of the number, you can have an np.array and the list that you have as a one-dimensional array. So you can define two-dimensional array, which is a matrix, and you can define that by a list of two other lists. For example, we have a list which is 1, 2, and another list 3, 4, and we have both of them in another list. So we can define a matrix here, for example, 1, 2, 3, 4, as a two-dimensional array. So for you can also have a three-dimensional array, and for example, you have two metrics, and you define another list and append two metrics that you have, and finally you have a three-dimensional matrix. Okay. Many functions can be used in Numpy array, and for example, you can create a range by calling this function np.arrange and passing the numbers that you want, the number of for example, here we pass 5, and the array that we get from arrange is 1 and 0, 1, 2, 3, 4, which is the range by defining this function, by calling this function. And you can pass other parameters to Numpy arrange, and you can pass the start point, end point, and the step size. And for example, here we pass 0 as a start, 10 as an end, which is exclusive, and the step size that we want to have in the output. So after calling this function, we can have 0, which is the start, and stepping by 2, we have all the other numbers. And another useful function in Numpy arrays is linspace, and for specifying a number of points. And this can be the parameters that we pass to this function is the start and the number of points that we pass to this function. For example, here we the start point is 1, and the end point is 1. The start point is 0, and the end point is 1, and we want to have 5 numbers between these two numbers. So as you can see, this is a start point, and this is an end point, and we have 3 other numbers by a same distance between them. So these are functions that can be useful in your program. And also another one which can be useful to create an array filled by ones. And for example, here np.ones, and you can pass the numbers that you need to have in your output. For example, here we pass 5, which means that we want 5 ones in the list, and the output is just like this, which is a list of the one as for each elements that we have in the array. And also you can have another function which is numpy 0, and you can pass a matrix or list or a tuples or a numbers. If you pass a number, the numpy 1s and 0 generate a list for you. And if you've passed tuples, the numpy 0s and 1s generate a matrix for you. So the numpy can support numerical data type and also strings, and you can also create an array in numpy with specifying the type of integers or floats that you want. For example, if you want to have an integer with 16 bits, you can define by np.int 16. That would be applied for other types. For example, here we just create an array filled with ones, and we mentioned that the output, the data type for each element of the list should be np.int 32. And also you can define float or boolean for the data type that you have in the numpy array. For example, here we just define 1, 2, 3 as an integer, but the data type that we want for the output is the float. So after defining this, you can have float numbers in your list after generating this an array. And if you define another array, the numpy with 1, 0, 1, and define the data type for boolean, because we consider 1 as a true, so the output is true, false, true, and because the 0 is false, the 1 is true. So as you can see, you can have different data type in defining the array in the Python. And also numpy support arithmetic operation and mathematical operators. For example, here at the first we define a list, an array, one-dimensional array, and plus 2. This means that we are adding each element of this one by 2. So after defining this line of the code, the output is 3, 3, 3, because this generate array, one-dimensional array, with which each element has a value of 1, and then we add the 1 to 2, and then the output is 3. So the important point here is that after having this operation on numpy array, each element will be added by 2, and this is an element-wise operation. Same thing happens for the subtraction and multiplication and dividing by 2 in the last line of the code. And as you can see, all of them are element-wise operation. And also you can have, here we just have an operation between the numpy array and numbers. You can have them between arrays. So that would be also element-wise. For example, here we have np.arrange, and for example, 1, we pass parameters 1 and 4. And also we have another one exactly same, but the output is 2, 4, 6, because this can return 1, 2, 3. and another one, we have another array here, which is 1, 2, 3. And after adding them element wisely, so we have 1 plus 1 as a first element, 2 plus 2 as a second element, and 3 plus 3 as a third element. Obviously, if you have a list of 1, 2, 3 and subtract to another array, which is the 1, 2, 3, so the output is 1 minus 1, which is 0, 2 minus 1, 2 minus 2, which is 0, and also 3 minus 1. And note that we can have also multiplication between two arrays. For example, 1, 2, 3, 1, 2, 3, and then the output is the multiplication between each element. 1 multiplication by 1, and 2 times 2, and 3 times 3. And note that this is not matrix multiplication. This is just element-wise multiplication between elements in two arrays. And also we can have same thing by dividing two arrays. Python has a specific function for matrix multiplication that can be used for generating matrix multiplication, and you cannot use this for this purpose. So you can also use logical operators on Numpy arrays, and for example, here you define an array and an array by np.arrange 4, and this can return an array with members 1, 0, 1, 2, and 3. So each element should be, if each element is equal to 2, we return a boolean for that which is true. Otherwise, we return false. For example, here the output is a false for the 0, false for the 1, and true for the 2 because 2 is equal to, and also 3, which is false because 3 is not equal to the false, to the true. And you can also have other logical operators. For example, mode here. We define an array and we get the mode by 2, and then check that if the mode of that element to 2 is equal to 0, then we return true. Otherwise we return false. For example, here 0 mode 2 is 0, and 0 is equal to 0, so the first element is true. And for example, here also 1 mode 2 is 1, and 1 is not equal to 0, so we return false. For 2 mode 2, we get a 0, which is equal to 0, so it's true, and also same for 3, which is false. Other operation that we can use for the NumPy arrays are less than, and here we have an array for 1, 2, 3, 4, and we want to check element wise for that if each element is less than corresponding element in another array. And for example, here 1 is less than, 1 is not less than 0, so we return false. 2 is less than 9, so the output is true. 3 is less than 9, the output is true, and 4 is not less than 0, so the output is false. This is all I want to talk in this lecture. And if you have any question about these lectures and the assignment, you can post on Piazza or email me, and we can discuss to find solution for that. And that's it. Thank you. Have a good day.